welcome back to our channel Code with Saransh, and today we are going to cover the Boolean expression part 2. So, if you haven't watched part 1, so go watch then and then go to part 1. You can find a video or at the end of the video, or just go to our channel and subscribe, like, and also watch the video. So, oh, Oh, in part 1 we got a quick recap. So in part 1 what we have done, we have covered variables, which we already done, if else statement, which also we already done, and the most important OR operator. So in part 2 we are going to cover the advanced option, um, and we and not operator, and truth tables. So let's start our video without wasting any time. So here back in our desktop. So let's open our VS Code, and now the first topic we are going to cover is truth tables, the table of truth. So let me give you the example. Why it's not opening? Oh, it's open too. Okay. So the truth tables shows every possible outcome and expression. They prove that our logic works in every single scenario. Let's look slightly a complex expression A and bracket B or C. So here's our program. One of we have the three variables. You can see, okay, yeah. A is true, B is false, C is true, and now we make a variable result, which we have equal, and A true, A the value of true, and it should be with it this. If A and B, it should be true. If A and C, it should be false. That's the truth tables work. And B or C, E. Print result, the variable result. Wow. Here the B is false and C is true. So B and C is true. Then true and true gives us the final result of true. Truth table help us to map out all the possibility and ensure our complex logic always correct. So let's go to our second topic is logical equation simplification. So we have now cleared the AND operator. Now we are going to logical equivalence in a simple word, simplification. So logical equivalence means two expression looks different but always have the exact same result. The goal here is efficiency, replacing a long expression with a shorter equivalent one means faster program. So, and we will demonstrate the absorption law. A and bracket A or B bracket close is equivalent to just A. Let's test both sides in Python to prove they match. So let's open our program to .py. So now we make A equal false and B equal true. Actually, we are understanding the absorption law of Boolean expression. So Now left side, left hand side, let's make a variable and also name it left hand side equal a or a and b. Now right hand side, which is also RHS equals a. RHS equal false, and LSH in the program when you have already seen, it means the indirect way of explaining the variable is true. So now do they match? Let's see. So let's use our print function, LHS in LHS is equal RHS RHS. So now let's the variable name simple. Now what we do is do this. Now make a enter and write LHS equal R LH equal RHS. Oh, why the S is becoming small? RHS. Now let's print the output. Output LHS false equals RHS. We forgot the bracket. No. False. I accidentally, oh no, HS output should be this. output should be this. This is our prediction for after doing all our science brain, maths brain, programming brain, all the brains in the one focus, and our prediction is this. Let's see, Python program 2.py. Oh, oh, F. Why F is has the error? Let's see. Was not close. Oh, what's the problem now? Now our program is solved. Let's run it now. False. Yeah, our prediction is right. LHS equal false to O equals RHS equal false. So why it's true? It should be false. Wait a second. There's a problem. Let's copy and paste. Okay. Oh, so our prediction is right and whole program is right. Since the output is true, we know the expression are equivalent and we can just replace the complex left hand side just with just A and cleaning up our code instantly. Now, let's have De Morgan's law, the nation trick. De Morgan's law is an essential transfer complex negation. Tell us how to distribute the not operator over and or. We will focus on law 1. Not or bracket A and B is the same as not A or not B in bracket. So first we will understand and the are not operator. Not operator is used when something you don't want. Like not operator often represent exclamation point or the word not, depending on the context of the programming. Is a fundamental concept in Boolean logic or Boolean expression and is used as a variable field, especially computer science and mathematics. So that's the our our not operator do, and let's and we I have example name De Morgan's law. So De Morgan's law. We have search. Imagine you have denied access is if you do not meet argument A and requirement B. De Morgan's law say that is the same as being denied if you fail not A or not B. Let's prove this with Python using not keyword. We will set A and equal true and B equal false. Now let's make our program 3. So program 3. So in program 3 what we are going to do is that uh, we will, as I say before, A equal true, B equal false, or left hand side equal same. But remember the law I tell you before, not bracket A or B. Right hand side equal not A or not B. Now print, let's print F equal LHS now real LHS and RHS dot match dot so nervous, very nervous because my LHS equal RHS. Now let's give him, yeah, yes, I think there's some problem. Okay, oh, okay, our program is solved. Now let's run. So both side evaluate is true. This power rephrases negated logic is invalid for writing efficient condition statements. So before I say it should be true over predicate, let's try it practically. So Python program 3.py enter. Oh, LHS equal by LHS truth table shows magic. My prediction got wrong, my explanation got wrong because LHS is equal to false because I already say not A or B. So or not A or B means nothing, so false. Also, and RHS equal not A or not B, so that's why it is match is false. So let's now the last and the final topic, advanced operators. Finally, let's look over the exclusive or XOR operator, which is unique and because it true only the inputs different A, B. In Python, the category symbol that one. Uh, let's what do I say it? Let's program 4.py. This one. Yeah, this one. I forgotten the name, but we will. So, tell me in the comment section the name of this symbol. Well, so let's start our last topic. So we use x1 equal true, x2 equal false. Now let's print test1. Okay, it's test1. Test1 print f true XOR true. Ooh, no. True. So here's our let's test one. Program or py XOR true, so it got false. Oh, I have to write x1 and x2. True x or true is equal true. So now let's run test2. Oh, test2. Test2 C. Control V and Control V. So as you have before seen it, it will false. Now, so there are two tested, we are completed. Behavior of this critical for tasks like checking data, partially impediment, cryptographic operations where we need to know if two inputs are exactly the same as different. So these are the essential tools for truly mastering the truth Boolean expression. We covered truth table, logical equation for equivalency, the transformation of power de Morgan's law, and the unique XOR. Practice with the simple Python program. They are the foundation of all computer decision making. If this video helps you for learning Boolean expression full and part 1, and also hit the like button, subscribe if for more videos. Till then, keep coding, keep learning.